Hello, everybody. This is Dr. Reed Van Ham with another Tonal Fungus Tuesday. I wanted to welcome all of you. Today, I would like to share a webinar I gave a few months ago about the physical and chemical challenges in treating onychomycosis. In the presentation, I'm going to talk about the structure of the nail and the challenges in penetrating into the nail and to reach the nail bed. I'm going to also discuss how to overcome those challenges in order to cure onychomycosis. Feel free to reach back with any questions you may have. As a scientist, I'm always happy and excited to answer any questions. Enjoy. So today I gave these presentations a few times. However, this time I wanted to focus on the challenges of finding a really good treatment to onychomycosis. So we are going to go through and understand why it's so challenging to treat it. So let's dive into the problem. So I just gave you a background of what's out there and why it's so important to treat it. So let's dive into the nail structure. So I'm going to describe the nail from the micro, how it looks on the micro level, and then on the micro level. So basically, nail, in terms of physiology, it serves a purpose. The purpose is to be a barrier between the environment and the nail bed. What happens when people get infection is normally because something happened to this barrier, and fungus and sometimes bacteria, sometimes it starts from tinea pedis, so it finds its way through cracks, or if women go to pedicure, so it finds its way to the nail bed. So here you see the structure of the nail. So there is the nail plate and there is the nail bed. The nail plate is made out of keratin, which I will show you in the next slides. It has a very compact structure, which doesn't allow penetration of drugs. It has hydrophobic properties, which means that it doesn't like so much for water to penetrate in, and the purpose is to block contaminants. And it has a thickness, also doesn't help too much. Normally the drug properties that kills fungus, normally they are larger molecules. They have low affinity to keratin, and they are not ionized, so they are not plus or minus, and they are not soluble in water. So keratin is serving lots of purposes not only in humans, but also in animals. So it's making up hair, nails, feathers, horns, claws, hooves, and other things, and nails, of course. And it's the other layers of skin among vertebrates. So it's actually protect the skin from damage or stress. Keratin is extremely insoluble in water and organic solvents. Nevertheless, they are among the toughest biological materials that are known to humans. And actually, it's brought many scientists to try to mimic the structure of keratin and to make strong materials for other purposes. For example, so as I said, nails and hair and fur actually is made out of keratin to protect against the environment. So this is in the micro level. So on the left-hand side, this is actually made out of, it's a structure of keratin. So it's a large molecule, and this is one part of the coil, but there are few coils connected together in bonds, which makes it, you see here, it's very tight and complex, and it's very, very hard to penetrate. Very, very difficult. So there are three well-known approaches how to overcome this problem. So one is mechanical, I will talk about it. The other one is technical, and the third one is physical approach. And those three approaches can be used to enhance penetration. It's all about how to enhance penetration through the nail to the nail bed, because this is where the fungus really likes to be. So the mechanical approach is, I am sure that most of you are doing it, it's actually filing down the nail abrasion. The chemical is trying to, using chemicals to make some pores or to soften the nails to allow penetration. One a very known chemical is urea. Solvent sometimes also helps to drag the active ingredient into the nail bed. And the last one is physical. So one of the known physical physical activity is ionotophoresis. It's actually when you have a molecule that is charged, so you put the patient's feet on the other, like on the negative charge, and then the molecule withdraw into the charge. It's like a battery. So for example, in our case, our molecule is very, very small, the molecule that ToeFX is using, and it's positive. So if we would put a flat sheet that charge negative, so the molecule will withdraw better from the nail into the nail bed. Another, all the physicals are lights that have some sort of penetration ability into the nail bed. Laser can penetrate, and photodynamic therapy, it depends on the wavelengths. Some of the wavelengths penetrate less. For example, green, yellow, blue penetrates not as deep, but red, for example, is the one that ToeFX is using, can penetrate 3 millimeters, which is a lot, into through the skin. So this is how it looks like. This is the nail. And as I said, in chemical strategies, one is penetration enhancer. It's urea or other solvents that enhance it's like a vehicle that enhances the penetration into the nail bed. And the other one is filing down the nail, as I said, and sometimes micro drilling. So for example, in ToeFX, one of the mini study that we are doing with those very, very complex and severe cases that are very challenging, people that have it chronically for 50 years, and it's very complex. They sometimes have secondary affection and other modalities. So we are trying to see if micro drilling the nail will improve in those extreme cases the efficacy.